Hello everyone, this is Vijay. Welcome to LN Academy. Today we are understanding the concept of circular motion in the simplest way possible. Let us begin. A chain of mass m and radius r placed on a smooth table is revolving with a speed v about a vertical axis coinciding with the symmetry axis of the chain. Find the tension in the chain. After reading the question, we got some points. The chain of mass m and radius are revolving in a circular path with angular speed omega. A chain of mass m, radius r is revolving in a circular path with angular speed omega. And second point is, due to this angular speed, the chain is experiencing a centrifugal force which is denoted with Fc and acting radially outwards. As angular speed omega increases, centrifugal force increases. As centrifugal force increases, tension in the chain increases. Our target is to find out the tension in the chain. To find out the tension in the chain, consider a elemental part of the chain which subtend an angle d theta at the center of the chain. And assume that this is the elemental part of the chain which subtend an angle d theta at the center, and mass of the elemental part of the chain is dm and the length of the elemental part of the chain is dl. And consider an elemental part of the chain of mass dm, length dl, and subtending an angle d theta at the center of the circle. And the elemental part of the chain is experiencing centrifugal force that is denoted with Fc radially outward, and it is given by Fc is equal to dm v square by r. Let this equation be 1. And this is the centrifugal force which is acting on the elemental part of the chain, which is given by Fc is equal to dm v square by r. And the imaginary axis of the centrifugal force dividing the angle d theta into two parts, that is called d theta by 2 and d theta by 2. And tension is acting along the edges of the elemental part of the chain along the tangent of the circle. Here, tension is acting at the edges of the elemental part of the chain along the tangent. Let this be T, and again this side tension is denoted with T, and tension can be resolved into two components. Horizontally it is T cos d theta by 2, T cos d theta by 2. Again this side T cos d theta by 2. This is due to the angle made here d theta by 2. Here the angle made is d theta by 2. And particularly another component is T sin d theta by 2. In this side T sin d theta by 2. And T cos d theta by 2 and T cos d theta by 2 are cancelled each other. This is because they are equal in magnitude and opposite in direction. That is why they can be cancelled each other. And the remaining forces of the tension are added up and acted as centripetal force, which is acting toward the center of the circle. That is T sin d theta by 2 plus T sin d theta by 2 are acted as centripetal force, and which is acting toward the center of the circle, and this centripetal force balances the centripetal force which is acting away from the center of the circle, and it means 2T sin d theta by 2 is equal to centrifugal force. It means 2T sin d theta by 2 is equal to centrifugal force is dm v square by r. If d theta is very small, we can write sin d theta by 2 is equal to d theta by 2, so that we can change the formula as 2t d theta by 2 is equal to dm v square by r. Let it be equation second. Linear mass density of the total chain is given by lambda is equal to m by 2 pi r. Here lambda is called linear mass density, m is called mass of the total chain, and 2 pi r is called length of the total chain. And linear mass density of the elemental part of the chain is given by lambda is equal to dm upon dl. Here lambda is called linear mass density of the elemental part of the chain, and dm is called mass of the elemental part of the chain, and dl is called the length of the elemental part of the chain. And but dl is equal to, that is called arc of the elemental part of the chain is equal to radius of the circle and angle subtended by the elemental part of the chain at the center of the circle, that is called rd theta, and put this value in this equation, so that we are getting lambda is equal to dm upon rd theta. Otherwise dm is equal to lambda rd theta, and take the lambda value from here. dm is equal to, lambda value is m upon 2 pi r into rd theta, then r are cancelled. dm is equal to m d theta upon 2 pi. Put this dm value in the equation second, that is 2t d theta by 2 is equal to m d theta upon 2 pi r into v square. D theta are cancelled. 2 and 2 are cancelled. Write the remaining entity. T is equal to m v square upon 2 pi r. This will be the answer. That is called tension is equal to mv square by 2 pi r, and this is the particular answer for the given question. Thank you. And take the lambda value from here. dm is equal to, lambda value is m upon 2 pi r into r d theta. Then r are cancelled. dm is equal to m d theta upon 2 pi. Put this dm value in the equation second. That is 2t d theta by 2 is equal to m d theta upon 2 pi r into v square. D theta are cancelled. 2 and 2 are cancelled. Write the remaining entity. T is equal to m v square upon 2 pi r. This will be the answer. That is called tension is equal to mv square by 2 pi r, and this is the particular answer for the given question. Thank you.